So I'm happy to kick off. So welcome everybody today. Thank you so much for coming to the next iteration of the Synthetic Data Workshop series. Today we have something slightly different take coming from industry. Merve and Lorna will speak more to it, but the insurance sector are feeding in now to our musings on synthetic data and how to do it well and what its applications may be and lessons learned. So I'll hand over to Lorna. Will you be kicking us off, or Merve? Lorna.
Yeah, it's going to be. I've just sent the email to Jade, yourself, and Merve. If either of you have it and could share it.
Perfect.
Hey, do you mind sharing? I might have to drop off a bit early.
Okay, absolutely.
If you don't mind, thank you.
Perfect. Okay, so the email is yet to reach my inbox, but I'm sure it'll be here any moment. Whilst we're waiting for that, feel free to introduce yourselves at your own leisure.
Yes, sure thing. Yeah, I'm Lorna. I'm a lead data scientist at LV. I've been with the company for about 3.5 years now. Before then, I was doing a PhD in biology, so a little bit different to the world of insurance. But yeah, I've worked on a range of different use cases, but synthetic data is one of the research ones that I did. Merve, do you want to give a brief intro?
Hi everyone. I'm Merve. I am in the data science team like Lorna. I'm head of academic partnerships and research. I've been with LV/Allianz Personal for the past 5 years. I was doing a PhD at University of Warwick and the Alan Turing Institute in data science before joining LV. So Jade, I'm not sure if you've received the email. Oh, you received it. Okay, I'll stop talking. It will be Lorna presenting today, so I'll just mute myself and turn my camera off. But I'll try to keep an eye on the questions as well, in case I can give a hand to Lorna.
Awesome.
Perfect. Should be coming up any moment.
Yes, that's good.
Wonderful. Be just. Okay.
Yeah, amazing. Great. Thank you very much for that, Jade. Sorry, classic technical difficulties. Yeah, so if we go to the next slide, there'll be a lot of this, I imagine. But yeah, just at sort of like a high level, I'll do a little bit of maybe introduction to who we are at LV and Allianz, and then through some of the internal research projects that we've done, and then kind of what our current outlook looks like. Yeah, so if you can go through to the next slide. Next slide. And we'll skip this one as we've done some personal introductions. Yeah, so a little bit of a background to the company. I mentioned LV and I mentioned Allianz. But so I joined the company as LV, and we're sort of the LV data science team. Oh, is my audio all right? Am I breaking up?
You are breaking up a little bit, yeah.
Okay, maybe I'll try without the headphones. Oops. Okay, maybe I'll just turn my VPN off as well, because that sometimes. Okay, is that any better?
We've lost sight of you though.
Okay. My camera says that it's on. I can see myself. It might take a bit of time to turn on.
Okay.
Yeah.
Can I?
Oh, there we go.
Sorry, I was just saying. Can I just reiterate those that aren't speaking? Please mute your microphones. Thank you. Sorry there, Lorna. Thank you.
That's all right. Okay. I tell you what, I might just turn my camera off just because it might be my internet playing up a little bit. So I'm sorry, I don't want to. If hearing me is more important than seeing me, I guess. And I can put it back on afterwards. Okay, yeah, please shout if it drops again. But yeah, so when I joined the team, we were LV, but LV is sort of a UK insurance company, and a few years ago we were bought by Allianz, which is like a global insurance company. So technically, we at LV fit under Allianz Personal, sort of the UK personal lines insurance arm. So that includes things like your car insurance, home insurance, there's breakdown cover, there's pet travel. So anything you would want to sort of insure personally, that's where we come in. And then, oh, next slide, please, Jade. They're within sort of Allianz Personal or AZP. There's kind of lots of different departments. So you've got claims, you've got fraud, marketing, pricing, other different areas, and we fit in like a little bit like a internal consultancy. So we work with different teams and departments to sort of try and bring machine learning and data science to these business decisions. Next slide, please, Jade. One of the one too many slides. There we go. So one aspect of kind of our work that fits alongside the more traditional use cases where we'd be working with claims, say, is that of our internal and external research. Back in 2019, we started a partnership with the University of Bristol. That led to a whole sort of range of collaborations. We gave guest lectures, co-developed MSc programs, and working at projects from like undergraduate to postdoc level. And we've since then moved on to a number of different universities. So one of which is sort of University of Exeter, which is why we're here now. Often the results of these collaborations sort of feed back into our working practices. But in addition, we also run sort of completely internal research projects that are time boxed to maybe like 1 or 2 months, where we investigate something new, maybe try and build new tooling out that we can sort of incorporate into some of our more standard project work. And that's really where the synthetic data project comes in. The majority of the work that was done on our team sort of within the subject kind of fits into that kind of internal research piece that we did. So next slide, and next slide again, please. Before we sort of dig into exactly what we did, I guess it's worth touching on briefly like why we wanted to look at it in the first place. There's a few different angles that we've got here. So firstly, we can sort of use synthetic data to maybe, well, can we use it to increase the performance of our models? So whether that's using synthetic data to sort of address imbalance in our data set, or maybe make better imputing decisions, or generally just like increasing the size of maybe some of our smaller data sets. With the end goal of kind of all of these, trying to make it easier for our models to learn and make predictions with a higher accuracy. Another angle that can, I guess, sort of link back to what I was saying before was maybe like working with universities, for example. So we would really like to be able to share our internal data with researchers who are working on like a collaborative project with us to really sort of like drive that research forward and make sure it's sort of be able to be translated into practice. Or maybe we run sort of outreach pieces. So, we run like datathons or hackathons with university students in the past, and it would be nice if we could share some of our real data with them. But obviously we can't go out giving customer information to outside sources. Even without sort of information like names, you might still be able to identify customers like private or sensitive information if you have their data. So yeah, even if like researchers are trustworthy, as soon as the data leaves our sort of systems, it's out of our control and could easily leak out. Even within Allianz, we aren't actually really able to share our data with other operating entities, say the Allianz arm in Germany. If we were collaborating on some kind of tool or training, we couldn't just send over our customers' data. So maybe like in an ideal world, we could share a synthetic data set based off our data, but with sort of sufficient privacy guarantees. Obviously, for like different levels of sharing, there will be different guarantees. So, it would probably be easier for us to share with another Allianz team than with University of Bristol undergraduates. But yeah, that's another potential use for synthetic data with our team. And then final point on this slide is for testing purposes. So we need to like robustly test that our models perform the way in which we expect them to perform, say across different environments. So we can either use our own data, which is maybe not ideal if we need to sort of upload that data somewhere to test it, or like really simple generated data, or potentially more complex real synthetic data. And I'll touch again on this a bit later. But yeah, that's the main options of uses that we would have for synthetic data with our team. So yeah, if we move on to what we've done next, thank you, Jade. So yeah, to start with, we wanted to get a better understanding of the synthetic data space. None of us in the team are experts, so you know, we've kind of picked up this knowledge as we've gone along. We didn't want to sort of reinvent the wheel. We wanted to see what open source packages, what the open source space looked like for practitioners. But before we could try anything out, we needed like data sets to try them out on. The majority of our models that we build within the team are on tabular data, so that's kind of what we focused on and what the rest of the talk is going to be focused on. So we chose a couple of like internal to us data sets that we used for a classification and a regression problem. They were kind of relatively easy problems to predict. So like the class imbalance in the classification was about 15%. And the models have been like productionized, so everything was in like a good state for us to work with. Next slide, please, Jade. We then carried out a bit of like a search for sort of suitable open source tools. I will say this was a couple of years ago now, so I know a little bit more exists in the space maybe, but at the time the Synthetic Data Vault, or SDV, was like the outright winner. It had really good maintained code and different modeling options. There was a Quip tool that was based off the SDV package itself, and the data synthesizer one that when we tried it produced really bad results, so we spend any more time talking about that. I'll focus on the SDV package. Next slide, please, Jade. So yeah, within this package, it has 4 different sort of generating modeling options. You've got sort of your more knowledge-driven approach at the top with a Gaussian copula, through to more sort of data-driven generative approaches with your GANs and your autoencoders. The copula GAN in the middle there is meant to be a bit of a bridge between your Gaussian copula and your GANs. You can sort of identify or define your distributions of features and things like that. So yeah, we kind of basically just tested all these models out on some data sets. Next slide, please, Jade. I'm not going to show you all the results from all the tests we did, because that's like a lot of tables and no one wants to sit through that. But these were just sort of like a bunch of different evaluation that we did. This is just like some of them. You've got things like, you know, how did it perform in machine learning models? How did it handle correlations and missing data, as well as sort of more statistical tests you've got there. There wasn't sort of one thing that we could use to say yes or no, this was good enough. So it's more of like a general look and to see how other people evaluated it in the field. There is a bit at the bottom, number 8 was privacy. And yeah, I will say that the majority of the things that we looked at really were on the utility side for this use case. For this research project, because you know there's lots of hurdles to overcome legally to share the data that requires us to look at those sort of privacy scores, but it's a lot easier for us to focus on saying, does this give us what we want, to say like improve our models. We don't need to go through like lots of legal hoops. So this sort of introduction was definitely focused more on the utility side of things. Next slide, please, Jade. This was just one example that's a bit more like visually appealing. Was just looking sort of generally looking at the distributions, less sort of quantifiable, but yeah, this was for one of it was for the classification problem. So top left you can see this is the distribution of the real data, and it's split by the positive and the negative class. The positive class is in orange. So you can see that overall there was more zeros, but within the positive class, 1 was the most popular value. And then how the models fared on this specific field, you can see that Gaussian copula and copula GAN didn't produce any of the positive class in this case, but at least the copula GAN kind of had the similar distributions, whereas Gaussian copula didn't really work at all. It's just 50-50 split. The CT GAN and the autoencoder did produce a positive class. Both showed this sort of right-ish distribution, but it's not really matching the real one. So yeah, this was just sort of one of the easier to look at results. Yeah, next slide, please. I'm not going to go through all the results in depth, but this is kind of just a pretty basic slide of how, in general, the models did. So again, mainly on the utility metrics. The AUC scores here are the scores when the model was built off synthetic data and then tested on real data. Just to give sort of an overview, I think the real data then tested on real data was about 0.9, 0.95. So yeah, the autoencoder, the CT GAN, was sort of closest to that. The autoencoder had a better AUC score, but maybe the CT GAN had slightly better other metrics, so they came out kind of similar on top. The Gaussian Copular GAN sort of did worse, while the Copular GAN, we couldn't generate any positive classes for that one. So yeah, this is though just sort of, you know, out of the box result. There wasn't any tuning done, and the results were okay. I did want to try out some tuning approaches, but yeah, the models themselves are really computation expensive. We had to do it on GPUs. So to do any like searching on the full data set would have taken days and days and days. So next slide, please. I did sort of take a small sample of the training data to do the training on. And after that, the Copular GAN actually just outperformed the straight out of the box models in the previous slide. And actually, the CT GAN and the tuned autoencoder did worse than the untuned one. I think that's just a result of me having to use a small sample for tuning. But yeah, I think that's something we kind of quite often see, that GANs in general require a bit more tuning than autoencoders, that are maybe a bit better straight out of the box. But given the fact we had to use a small sample for tuning, there's not like a guarantee that it would help, you know, as we saw here. And given the sort of time and compute cost required, we ideally wanted to perform like as minimal tuning as possible. But yeah, that was kind of the first phase, just a general look and explore into the world of synthetic data, just try and sort of upskill ourselves a little bit. Next slide, please. The second phase that we wanted to do is a bit more like directed. Can we use it for something? And that's something in this second phase was for imbalanced data. So next slide, please. Yeah. A number of the sort of typical projects that we work with often have really big class imbalances. If you think of fraud, for example, out of everyone who makes a claim, I imagine, you know, only a really small, tiny number of them will actually be fraudulent. So that makes it obviously a tricky problem to solve. And often we have to try and use different approaches to try and sort of improve our predictions. So this kind of little short research piece we did looked at, can we use synthetic data with sort of like a GAN approach to effectively like sample the minority class. So we use the STV package that we used before, and that has a condition parameter you can set, so you can enforce the generation of a certain data point. So for example, we only want to generate fraudulent data points. And then merge that back onto our original data set, compare results sort of with and without synthetic data. We also compare the results to sort of more traditional synthetic generating approaches like SMOTE and Edison. Next slide, please, Jade. We've got like a graph here on the right hand side that shows the performance over the number of data points added, sort of baseline performance without any additional data points at the top in blue, and it's kind of probably too small to read on the y-axis, but the actual difference between the values of the AUC score is really, really tiny. I think it was like 0.935 at the top and then 0.931. So yeah, no approach really improved performance over the baseline. Potentially at that first instance, that Copular GAN just sneaks above the baseline at the beginning, but kind of given the computational complexity of running a generative model just to get that tiny kind of improvement, it wasn't worth the results. So really the outcome of this was it didn't really improve performance on top of the baseline in this specific case, and we'd recommend that, you know, if we wanted to upsample to improve performance, that we would suggest sticking with like your traditional SMOTE or Edison that was a lot quicker, a lot easier to generate and test out. Yeah, next slide, please. On to phase 3, and that was about testing data. Next slide, please. Yeah, as I mentioned before, when we're productionizing a model, we want to make sure that it performs the same across different environments, and we need to perform reconciliation for that. we normally use a randomized data set, so only using the the minimum and the maximum values from the real data as like bounds for generation purposes, and then that stops us having to push customer data. But as you can imagine, that's just a sort of completely random distribution. It doesn't match the real data at all, and we can often run into errors because it doesn't necessarily consider, well, it definitely doesn't consider the relationship between columns. So you could have like the date that a claim is made for a crash happening before the date of the crash happening, or column A is value 1, column B has to be negative, but if column A is 0, column B has to be positive, or sort of weird sort of constraints like that. It's hard to enforce the kinds of rules with a really basic randomized data set. So yeah, it means that we often end up with unrealistic data, can cause test to fail or the model to return an error. And the only easy way around this is to set like hard-coded values for entire columns, which kind of limits the amount of testing that we may be doing. So this project was to see if we could come up with an alternative approach to generate sort of feasible testing data. Next slide, please. Yeah, so we tested out 2 different methods. Firstly, the sort of generative methods I've been talking about, the GANs, and then we also tried out something called polyfactory, was previously called pydantic factories, and yeah, that's kind of based off schemas. So you just sort of generate a schema, and then this generates data based off that, and you can make use of validators to sort of enforce constraints, and you reject data points if they don't meet the requirements. Similar to that, the SDV package allows you to set cross-column constraints. So, for example, column A always has to be bigger than column B, and things like that. Sadly, again, for this project, the sort of computational complexity and I guess the sort of heavy dependencies means that the synthetic data wasn't really suitable for this, which was a shame because I did feel like we were producing more real testing data using a generative approach, but that the negatives in this case outweighed that positive. Next slide, please. So yeah, that's kind of what we've covered internally to LV data science team to date. The final bit is around a bit like knowledge sharing, I guess, a little bit. Next slide, please. Yeah, as I mentioned at the beginning, one of the potential reasons for synthetic data is around the privacy angle. And yeah, obviously, insurance industry, very heavily regulated. We have sort of regulatory bodies like the FCA, we have to comply with them. And in general, insurance companies are meant to be protecting their customers from harm. So we don't want to release anyone's customer data. So we've worked at within the wider Allianz group at sort of a global level to put together a bit of a framework or set of guidelines on how we should handle anonymization of data. And we at LV contributed to sort of how synthetic data fits into that. Talking about things like different generative approaches from knowledge driven to data driven. And yeah, that's kind of where we are at the moment in terms of what's happening within our team. Next slide, please. And then again as well. Yeah, so we've completed sort of 3 internal projects. Sadly, the second 2 didn't lead to us using synthetic data sort of regularly, but of the first phase, we are actually using one of the data sets that was produced solely internally, but as a sort of training purpose within our team. And then something that's actually kicking off a little bit more now is sort of cooperating with other operating entities or OEs in a bit of a synthetic data working group that spans different countries with a focus primarily on the privacy angle that would allow us to share data internally. As I said, we can't do that at the moment. Yes, that's something that's starting to kick off, and it's quite interesting. But yeah, next slide, please. I think this was just some challenges that sort of in general that we have faced across the different projects and research bits that we've tried. I think the biggest one for us was the computational complexity required to train the models. Especially as the size of the data set increased, it took a long time. It's not it's not just expensive in terms of like compute cost required, but also the time to run, which sort of in turn makes them also really difficult to fine tune if you have big data sets especially. And yeah, although some of the models that are sort of built into the SDV package, for example, I think sort of the CT-GAN is one, it's meant to be sort of optimized to handle imbalanced data sets. It did struggle often to generate some, or if any, of sort of minority values, which, you know, it makes sense, there's fewer values to learn from, but yeah, it's definitely something that occurred quite quite a lot when we were running through these, and yeah, sort of imbalanced features it struggles with. And then yeah, the one at the end, privacy, we haven't researched it that much, but we're at that point with the wider Allianz collaboration where we're looking more in depth, and you know, can we ensure privacy while still maintaining a suitable level of utility? And yeah, I guess as sort of coming to the end now, a good opportunity to maybe utilize some of the knowledge in the virtual room. You know, we're still relatively early on in our journey of using and investigating synthetic data, but if anyone has any sort of particular recommendations of packages or models or sort of code spaces for like practitioners that are really specific to the sort of privacy side of synthetic data, then yeah, it'd be great to hear. If anyone has anything, put it in the chat, whatever. Yeah, I think that's the end of my slides, really. Apologies for the technical difficulties. Hopefully you heard that all right. But yeah, I'll put my camera back on, given that's over. But yeah, any questions?
Hi, Lorna. I just want to say thank you for sharing that. Did Merve, did you have anything else that you'd like to add?
No, it was all Lorna today.
Okay, thank you,
We would really appreciate any recommendation, just like Lorna said, in terms of what other packages, you know, papers with code, or any papers that you recommend us to look at, especially with the any privacy metrics, ways to ensure privacy. We would really appreciate that. But yeah, other than that, thanks, Lorna.
So I open up to the floor of our attendees. Any questions come to mind throughout the talk? If so, please turn on your camera and introduce yourself. Okay, no questions in space. I mean, I'm interested about this international synthetic data working group. Lorna, how's that looking at the moment? Have you kicked off that, and are you involved in other parts of industry or government or academia to pull in that knowledge?
So at the moment, it's sort of just starting to kick off. We're working on like a sort of a bit of a proof of concept, and oh no, can't turn off.
I'll
look
into that. Yeah, do carry on, Lorna, and I'll.
Thanks. Yeah, so it's just sort of starting to kick off, and we're carrying out similar things that we have done in our sort of research phases, but I guess that was a couple of years ago now, so it's more updated, and seeing if we can get anything different from that. I saw that there was something in the chat, so I'll answer have you looked at the NHS data and how they anonymise? I don't think I've looked at the anonymisation data of the NHS specifically. I guess we have, in those anonymisation guidelines that I talked about, we have a whole host of different approaches that we can use to anonymise data, but I guess the focus of the working group is maybe to create data that is sort of, yeah, completely private, so no one can be traced back through any data at all, and be good enough to build machine learning models off. But yeah, there's definitely a few different approaches that we need to look at, and I'll definitely make a note of the NHS one. The reason about the was a reason you didn't get an improvement with more data because you already had enough. What did the learning curve look like? Yeah, that's a good point. I think the data sets were pretty big. I didn't do that specific project myself, so I'm not 100% sure on the learning curves, but I think there's a chance that, I don't know, whenever I've tried with upsampling techniques in the past, it's never worked specifically well. I think because it's kind of like you're just trying to produce more of the same points that you already have rather than sort of expanding out. So I don't know if it sort of links back to that as well, potentially. But yeah, so I don't know. Maybe I wasn't too surprised that we didn't see an improvement with that one, but it was sort of worth a try.
Yeah, I mean, I think, I'm sorry, I've now managed to turn my camera on, and I mean, I think that it's worth thinking about. If you had more real data, would you have seen an improvement? And so certainly in the work, some of the work that we've been doing here, we've looked to make sure we're in a regime where adding more genuine data would actually have helped, because you may just have enough data anyway, or at least adding more just isn't going to help. And if adding more real data doesn't help, then adding synthetic data is likely to be, it certainly won't help, and it might be detrimental, I suppose. So
yeah, that's the
I think
point. It's kind of like
it might be
you
worth
want
looking
to
at.
expand the space rather than just more of exactly the same. Might potentially sort of more different data.
Yeah, absolutely.
Yeah, fair point.
I was so nobody else is asking a question, so I'll ask another one if that's all right. You showed right at the beginning, you showed some pictures of distributions, and I was a little bit puzzled by those. Yeah, there we are. So are these distributions of the features?
Yeah, so this is just one field, one feature in the data set, sort of by itself, may just looking to see what it looked like at like a high level. We also did certain like clusterings and things like that, but this was just literally one field.
But
it's binary.
Yeah. Okay, it looks as though it's just noughts and ones though.
Yes, sorry. Yeah, I say distribution is the wrong word for it.
Well, yeah, but yeah, okay. So but yeah, I guess it may not be that surprising that it's not working very well if if you're treating it as Gaussian distributed, which is what those pictures imply.
Yeah, I think it's potentially that's my plotting from 2 years ago rather than they are sort of zeros and ones. Yeah, no, I think that's a fair. I should update the graph slightly to make it a bit clearer.
Cool, thank you. Yeah, and then I mean, maybe this next question is, I'll shut up. There's another question. Yeah. Thanks.
All right. So yeah, what's your take on the training cost versus the benefit for the business when using your own data versus synthetic data and use of algorithms with sort of pre-trained massive data sets by OpenAI, or potentially mixing and matching potentially all of the above. Yeah, I mean, the cost was a lot, especially for the big data sets. Having to use the GPU and sort of run it for a few days. The benefits that we got were not good enough to warrant us using it, really. I know we've also looked into potentially using sort of commercial options. And yeah, I think for what we've needed it for, at least within LV internally, it's something that we're not required to do. We don't have to share data. So yeah, I think for us, I think there are better alternatives like the polyfactory thing that I mentioned for generating data for testing. Interesting on the using sort of pre-trained data sets and things like that is not something we've looked into yet. I think it's potentially something that we'll try and look into a little bit as part of the POC with the wider Allianz team. But yeah, at the moment, from what we've done, I would say it's potentially not a big enough benefit to warrant the cost from our end. Yes, yes. Don't mention the data. So I think the data was probably, it was quite big. It was about 700, actually, 700, 800,000 rows of data and about 100 columns for the classification problem. Yeah, so that was the kind of size of data sets that we were looking at. For the tuning, I had to take that like right down. But yeah. Obviously, I did try it with a few different variations of features, and it unsurprisingly was a lot quicker. It was quicker, the fewer in both directions, fewer rows, fewer columns. But yeah.
Well, I guess I would just comment. I think with that amount of data, you know, I think unless it's terrifically imbalanced, then you might use, I suppose there you might use synthetic data to generate some of the imbalanced class. That might, and I know you said that you were struggling a bit with that, but I wonder whether, or at least these methods were struggling with that a little bit, but I wonder whether it might be easier to separate the classes before you generate the synthetic data. So, you know, just separate out the minority class, generate data from that, rather than trying to do it all in one go.
I think that was something that was looked at as part of that project, and it kind of similar-ish results for that specific one. But yeah, it's a fair shame.
Yeah, but I would have thought with that, you know, with that amount of data, you know, it might be more fruitful to look at some other mechanism for preserving privacy, you know, like differential privacy or something like that. Yeah.
Okay, great. Yeah, thanks. Okay, we've got something in the chat. Synthetic data expert group being formed by the FCA. Yeah, I think Merlin might know more about this than us, but we definitely have contributed to, I think FCA had like sort of open calls about what sort of industry are using synthetic data wise, or what they would like to see from it. And we contributed towards that, right, Merlin?
Yeah, that was prior to this expert group being formed. They did, I'm not sure if you all seen it, they kind of released a request response from industry, whether industries are using it, why do they use it, and what are like the known challenges and bottlenecks around like use of synthetic data. So that's the one we did send a response from our learnings, and we don't have a representation in that as synthetic data expert group, but yeah, we are aware of it. Thank you for sharing. So.
I had a quick question. You mentioned earlier that you were interested to see other people's take on what they've used for different metrics, for example, privacy. I noticed you had tried a few different privacy metrics. Would you mind talking a bit more about what you've used so far?
Yeah, so I think I put them on the slide, but we didn't actually get too far with them because the focus was really on the utility one.
Sure.
So I think it's mainly been realistically reading around the privacy metrics, sort of the member inference sort of attacks, things like that. Things like, you know, similarity of data points to other data points and how close they are, or exact matches and things like that. But we haven't sort of dug into it yet absolutely as part of the working group, that is something that will happen, but for previous phases, it wasn't a focus.
Sure, thank you.
Also worth mentioning, also apologies for the background noise if you can hear it. I'm in the kitchen of our office because our office is getting moved. Long story. For the SDV package, I'm not sure if you're familiar with that. They do have a privacy metrics option. That was around 2 years ago. We tried looking into it, but it didn't work. It was like running for hours and hours and hours, just like not spitting anything out. So we weren't sure if it was we set something up wrong or there was a known bug back then. But it's a very it's the developers are very active, so that's one thing we again recommended in the internal interest group to look into it again, because they kind of have good functionality around privacy metrics. But if there are any specific metrics that you would recommend, we'd love to hear it.
I think we're possibly in a similar boat of just starting to explore it, so I want to see how other people are doing it. Did you say earlier that SDV is an open source package?
Yes, it is.
That's cool. I haven't come across it, so that sounds really interesting.
Yeah, it was developed by researchers in MIT based off of their papers, like maybe 3 years ago it kind of started. I think they spinned off a company at the back of it, but they still keep their open source package, and they keep making improvements to that. So it's really good and comprehensive package. And it's quite easy to use, like GANs, for example. You don't have to like directly do it from PyTorch. Quite a lot of things come kind of like bundled in nicely and fairly easy to use. I mean, Lorna, I'm not sure what you would say, but when I initially came across, I found that it was quite easy to use and quick to try on some of like the pilot cases we had internally.
Yeah, definitely.
Really cool. Thank you.
I'm wondering about this international working group. Will there be any sort of shareable, I guess, outcomes or best practices that could be available to this wider community here?
I'm not sure. To be honest, I guess on one angle, if whether the outcome will be anything above what we've already found, and then two, how much we'll be able to share. But if it's sort of like open source general stuff, I feel like that's something that correct me if I'm wrong about it, but I feel like we should be able to share. But I imagine it's going to be similar to what we found.
Exactly. Yeah, I mean, they are using us as the internal experts per se who looked into this the most among different OEs. So what they're trying to do is basically trying to find another pilot case study internationally and try those methods, because I mean, obviously our checks are a bit outdated now. Lorna found another package that can be quite useful. What was that, Lorna? Was that synthesizer? That wasn't there when we looked into it, so we're kind of like guiding them around which package would be fit for purpose, so then they're going to kind of go ahead with POC. So if we tend to find anything, oh yeah, by the way, actually, you know, they fixed the privacy metrics of SDV, we're more than happy to share. But like exactly to Lorna's point, I don't think there would be anything further. They're actually wanting us to ask you, the virtual room, like what else we could try out. And yeah, it's more like application focused POC, and because again it's like internal data, I don't think we would be able to share the details. But I mean, I suppose Lorna or I can let everyone know if there was something we found to be useful, like as a package piece of functionality and tool. And if you find anything, please feel free to just email us. It would be really, really good to, you know, try it out as part of this POC as well.
Totally. I will do anything that comes my way, and the invitation, of course, is extended to everybody else in the room. Unless there are any other questions, I'd like to flag the next talk we have on synthetic data, which is happening on the 29th of next month. Same time, I think 12 until 1, and we'll have Professor Fabrizio Costa talking. I will send out an invitation for registration post this meeting, with some more details of what specifically he's going to be talking about. The title is Looking for a Good Quality Measure for Generative Systems. So yeah, last chance for any questions. If not, I'll say lunch, everybody. Okay, take care. See you next month.
Thanks, guys.
Thanks, Lorna and Merve.
Bye.